So, take-home laboratory experiment part 3. Laboratory activity 1. The laboratory experiment on transistor. Our materials needed: breadboard, connection wires, lead, battery, and digital multimedia. So in figure 1, so this is our circuit diagram in figure 1. Okay, that's this in figure 1.
We will measure the voltage and current of transistor 1 and 2. First is the voltage drop of collector and base. .51. And voltage of collector and emitter. Same, 0.51. Voltage of base and emitter, 0. And now we will measure the current of the collector. Current of the base, 0. Current of the emitter, 0. Current of diode 2, and now we will measure the voltage and current of transistor 2. First, we set the multimeter to voltage, measuring the voltage drop of collector and base. .76 volts, and voltage drop in collector and emitter, 7.7 volts. And then voltage drop of base and emitter, 0.77 volts. And then measuring the current of the transistor 2, we set the multimeter to amps. First is the current of the collector, 0 current. And current of the base, 0. Current of the emitter, 0. That's all. And now we proceed to figure number 2. Having connection of resistor of American in series connection.
this terminal of transistor is indicated in the two transistor, two transistor. And the emitter is connected to the negative terminal of the battery.
Here's the circuit diagram, figure 2. And now we connect these two connection wires to demonstrate the figure 2.
To measure the volt between the base and negative terminal, at first we need to set our digital multimeter into voltage. We have 0.51. We have 0.54. Okay. In transistor 1 in figure 2, the voltage drop of collector and base. We have 0.73. For the voltage drop of collector and emitter, we have 5.3. For the voltage drop of base and emitter, we have 0.74. For the current, we need to set up our digital into current. So the current of collector you have 0 ohms. For the base, also 0. For the emitter, 0. For the diode or lead, also 0. That's all for figure 2. So in figure 3, we have 100 ohms of resistor, lead, and variable resistor, transistor, and connection wires. According to circuit diagram, we have a connection of resistor with parallel to the transistor. Okay, resistor connected to capacitor. And variable resistor. And then connection of this and resistor. And lead connected to capacitor terminal and collector. And the emitter is connected to emitter. This is our circuit diagram in figure 3. Let's try magana. Yun. This is now the result.
And now we proceed to measure the voltage drop of the transistor with minimum range of variable resistor. First is to set the multimeter in voltage, and then the voltage drop of the collector and base. get 1.70 volts. Voltage drop of collector and emitter 2.20, and then voltage drop in base and emitter 0.50 volts. And then measuring the current, first we set the multimeter in amps. The current of the collector 0. Current of the base 0. Current of the emitter 0. Current of the diode all 0 current, 0 amps. And then the voltage drop tapos transistor in middle range of the variable resistor. First is the voltage drop in collector and base. First we set the multimeter to voltage. And then we get 1.27 volts. Voltage drop in collector and emitter 1.86. Voltage drop in base and emitter 0.59. And then measuring the current, first we set the multimeter in amps. Current in the collector 0. Current in base 0. Current in emitter 0. Then we proceed to the measurement of the voltage and current in maximum range of the variable resistor. So we can see that the LED has a bright, very bright status. And then first we set the multimeter in voltage. We will measure the voltage drop of the transistor in collector and base. We get 0.58. And then the voltage drop in collector and emitter, we get 1.22. And then the voltage drop in base and emitter, we get 6.64. And then measuring the current, first we set the multimeter in amps. Current of the collector 0 amps. Current of the base 0 amps. The current of the emitter 0 amps. That's all. Thank you.